Hello everyone, my name is Sameeksha Upadhyay. I am a trainee under Sachin Walia sir from January 2024. I am currently pursuing BTech in Electrical Engineering and I am in third year. Today is 21st April 2025 and today I am going to dive into the concept in networking ARP, Address Resolution Protocol. Address Resolution Protocol help devices to find the MAC addresses with the help of IP addresses, or we can say that we can find the MAC address of any device whose IP address is already known to us. Without MAC address, we cannot transmit data from one PC to another. It is like IP address is like our name and MAC address is like our address. If someone wants to send anything to us, they should know our address. If they don't know our address, they cannot send anything to us. Just like that, if PC don't know the MAC address of the PC to which it needs to or it wants to transmit the data, they cannot transmit the data. And for finding the MAC address, we use ARP. ARP has two features, ARP Request and ARP Response. ARP Request is a broadcast message, which means it is sent to all the PCs or devices connected in a local network. An ARP Response is like a unicast message, which is only sent to the requester. In an Ethernet frame, we have a type field. In type field, we write 0800 for IP packet and similarly, we write 0806 for an ARP packet. In ARP packet, we have following features like first, source hardware address, which is like SMAC. Second, destination hardware address, which is like DMAC. Third, source protocol address, which is like SIP. Fourth, destination protocol address, which is like DIP. And fifth, which is type field. Type field has two types, 1 and 2. 1 is for ARP request and 2 is for ARP response. Now, let us understand the ARP with the help of some examples. So, first example. In a local network, if one PC needs to transmit data to second PC, for example, if PC1 needs to send the data to PC2, then it must know the MAC address of PC2. But we doesn't know the MAC address of PC2, so we'll do an ARP request to find the MAC address of PC2. So, first of all, PC1 will going to make an ARP packet, which will going to contain source protocol address, which will be the IP address of PC1, destination protocol address, which will be the IP address of PC2, source hardware address, which will be the MAC address of PC1, destination hardware address, which will be left blank. When we do an ARP request, there will be nothing in the DMAC field or destination hardware address field of ARP packet. And in the type field, we're going to write 1 because it is an ARP request. Now, this packet, ARP packet, will go to the second layer and encapsulated in an Ethernet frame. In an Ethernet frame, we'll have fields like SMAC field, DMAC field, and type field. In the SMAC field, we will going to write the MAC address of PC1. In DMAC field, we are going to write all F because we have to broadcast the frame to know at which IP address the frame will get accepted. Now, in the type field, we are going to write 0806 because our packet is being encapsulated in the Ethernet frame. Now, this frame will be sent out to all the ports in the local network, but it is dropped by all the devices except the PC2. PC2 will going to accept the frame. It will going to check the type field. In the type field, it is written 1. That means it's an ARP request. So it needs to send a response to PC1. It will going to make another ARP packet for a response. In that ARP packet, it will going to write in the source protocol address, the IP address of PC2, in destination protocol address, the IP address of PC1, in source hardware address, the MAC address of PC2, in destination hardware address, the MAC address of PC1. In type field, we're going to write 2 because it is an ARP response. Then this frame will again get encapsulated in Ethernet frame. It's going to become Ethernet frame. Then in Ethernet frame, in SMAC field, the MAC address of PC2. In DMAC field, the MAC address of PC1 because this is a unicast message. In type field, we're going to write 0806 because it is an ARP packet which is being encapsulated. Now this frame will directly go to PC1 because it is a unicast frame. PC1 will going to accept it, and in the ARP packet, it will going to check the SMAC field, which is the desired MAC address which we need to find out. Then from by this MAC address, with the help of this MAC address, the PC1 can transmit the data to PC2 easily. Now in example 2, we're going to take an example where the devices which needs to transmit data with each other are in two different networks. For example, PC1 wants to send a data to PC2, but PC1 is in another network and PC2 is in another network. They are connected with the help of a router in between. So PC1 will first going to send a ARP request where it will going to send it to a gateway which is on the router. Then the gateway, it will going to find out the MAC address of that default gateway. After that, it will going to transmit the data to default gateway, and then default gateway will continue the process till it will reach, the data will reach to the destination, desired destination. So when we are transmitting the data in different networks, like from one PC to another, which are in different networks, the ARP request will first go to default gateway and then to desired destination. This is all for today. If you guys like the video or understood the topic, then please do like the video. And if you have any doubt, then please drop it in the comment section. I will try to solve it as soon as possible. Thank you so much for watching.